For problem number one, it says, what is the centripetal acceleration of when you run a 7.6 meter per second around the curve of an Olympic track with a radius of 3.65? So let's kind of draw. For all physics problems, what we need to do is we need to draw the picture. Right? And so this is what they're talking about. You're running a track at an Olympic event, all right? And so the ends of this is actually a circle, all right? So you can kind of sketch this out. And let me just verify or show you guys how that's a circle. So if I take my little circle here, I can shape this to where it fits right there, okay? So that's really a circle, and I can fit it to that circle or I can fit it to the inner circle. Now, it doesn't matter if it's the inner circle, outer circle. It doesn't matter which lane you're in. They're talking about the radius with regards to the path that this person travels. So I guess I could go like a specific lane, maybe. So I could do something like that. And it's just an approximation, okay? And so what they're saying is that the radius, which goes from the center of the circle to the edge of the circle, at all points, this distance, all these blue arrows I'm drawing, they're the same distance. That's the definition of a circle, right? So the radius of that circle is equal to 36.5 meters. So this is 36.5. And then they say that the velocity is equal to 7.6 meters per second. Now, that's a linear velocity, okay? And it's tangential. So really we should, now that we're doing circular stuff, it should be v sub t. Now, what does that mean? That means that they're running with the velocity this way, but then when they turn the corner, that velocity goes this way, okay? And then lastly, we need to talk about the acceleration. Well, in order for you to change the velocity, the speed of the velocity is always 7.6. The only thing that changes is the direction. And remember that centripetal acceleration goes towards the center. So there's an acceleration that goes and pushes this way towards the center of the circle, okay? And so that would be the centripetal acceleration. Well, the centripetal acceleration then is equal to the velocity, the tangential velocity, which is really just the linear velocity squared. I don't know why I wrote cubed. This is a formula in your notes. Over the radius. So I've just got to plug that in and do the math. So my centripetal acceleration is equal to 7.6 meters per second squared, bless you, all over 36.5 meters. Okay? Let me slide that up for those of you in the back if you can't see it. Let me put my face over here somewhere. All right? So now if you plug that into a calculator, this ends up approximating to roughly 1.58 Now, I will confess that our textbook does some rounding too early. If you were to do the rounding like at a university in real research, you would just do all the math until the end, and then you follow the rules of significant digits, but the textbook they're just not consistent. Sometimes they just round it in the middle of the problem. So, anyways, that's the answer. Does anybody have any questions on that one? How many of you guys were able to do that one?